everyone. This is the last talk of the day. I hope to not get you to sleep, and you have the opportunity to learn something today as well. And let's start with a quick question. How many of you know about testing code? No? So I understand that you don't know about test-driven development either. Okay, it's a great opportunity to learn new things. So before, oh, what is? Okay. Before we start, a little bit about myself. I'm Anyul Rivas. I consider myself a software crafter. I'm a principal software engineer in Club Blue with about 15 years of experience in software development, mostly in web development, also with several areas like banking, insurance, healthcare, and most recently cloud platform. And I am also a member of Barcelona Java User Group, which is a non-profit association that is related to sharing knowledge about Java and other languages with JVM like Kotlin, Scala, or Ruby, and also about cloud technologies in AWS or DevOps as well, or Kubernetes, or anything that you would like to share. We are also open for it. I'm the organizer of the JVSN Conf as well. It's a huge conference that we have physically in Barcelona. This year we will have the 7th edition. We expect to have more or less what we have here in HackUPC, like 700 attendees. We will also talk about testing in Java, TDD, agile methodologies, cloud development, Kubernetes, DevOps, anything that you can think of. We even have talks about DevRel. If you don't know what it is, it's also something very interesting. And I am also a HackUPC mentor since 2017. And normally I post things about things that I learned or want to share on social network. You can find me on Twitter or LinkedIn with Anyul. And I don't know if you know who is Excel Dijkstra. It's very difficult to explain the name. If you don't know him, he's the one that invented the big O notation. It's something that developers use to measure the complexity of the code. When you are developing a solution, you can use the big O notation to tell if your solution is very complex or it's simpler. And he said one time that program testing can be used to show the presence of bugs, but never to show the absence of them. So you will never prove that your code has no bugs or that is perfect, but you can prove that the bugs that it has been resolved, or that the use case of the client is also validated. Is the best way to validate the client's expectation. So the agenda will be this. We are going to go about the concepts and why is it required, what are the steps, what are the benefits, what's the cost of delivering software, and some resources to learn with TDD. So what is TDD? It's a software development process. It's not about the testing. It's more a development software where you split the client's requirement into specifications that you can automatically test, and This is opposed to develop the software first and try it, test it afterwards. Normally, in our work environment, what we used to do is that we receive a requirement from the product owner or from some business analyst, and we dig right into the code and start coding, and then when we finish our implementation, we test it. So this approach is the other way around. We analyze what we need to develop, we create a test that it fails, and we code the minimum amount of code to comply with the solution, and then we perform a refactor. This is Ken Beck, is the one who rediscovered this technique like 20, 30 years ago. And why do you need TDD? Let's suppose we have a hypothetical situation. I hope that you don't be in this situation here in the hackathon, but it's Saturday night, it's almost midnight, you have 9 hours to deliver your code, and you are testing your integration with an API from the sponsor, and you are struggling with having the correct input. This is hypothetical. I think this never happened to any of you in the past. So you are in a team of another 2 hackers, and they are depending on you, and they are expected that you deliver the code properly, and you feel the pressure, right? So what do you do if you are coding in a server or in a mobile application or a single page? You compile the code, you start the server, or you transfer the binary to your device, and then you go manually to the use case, input the data, cross your fingers to get the expected output, and it's not happening. So you turn off the server, you go back again to the code, and do the same process again and again until you have it. So once you have it, then you realize that you need to refactor another piece of the code because the data structure is not the same, and then you need to adapt to the rest of the solution. And now you feel the anxiety because you have less hours to develop. The team is waiting for you. You are hungry, you are sleepy, and you want to deliver, right? So this is where TDD comes in. TDD will help you find the defects earlier, and also will help you detect regression errors. Also, it's a simple process to design and develop your code, and it will be easy to refactor the code after you have some tests passing. Because when you have your test in green, which is that all the test passes, you have a safety net. You have the freedom to destroy the code and do it again, or do modifications that will simplify it and make it more general applicable. And if it passes, it means that you're not breaking anything. But if the test goes red again, you have the confidence to do a reverse with the commit history and start over again, and you feel safe. So your software also be easier to test and maintain because you will be the first consumer. If you develop a testers, you will build the codes in such a way that will be testable. And you will be smart enough to make the code maintainable as well. And another point is that tests are living documentation. There's sometimes when we need to see another developer's code, what we tend to do is to go straight ahead to the production code and try to figure out what this recursion is doing, or maybe this one-liner that calls a lambda and does a closure. So instead of doing that and spending some mental time to struggle with the code, if you have well-written tests and well-written scenarios, you will have a narrative of what the code does, what are the business cases. You have some edge case as well, where the code needs to behave specifically. And this is what I usually do whenever I need to develop a new feature or resolve a bug, I tend to go to the test first to understand what it's doing. Also, there is a study that says that almost 90% of the code that is being built, no, almost 90% of the production bugs that I've found are easily resolved by automatic tests. So this is a huge amount, and you should pay attention to that. If you pay a minimal attention of having your tests covered, you can save a lot of time and a lot of money from the company building your code. And as a result of all of that, then the development cost is slower, is lower, is cheaper, and is also faster at the end. I must admit that the title of the talk was a catchy phrase to attract your attention, but at the end you will see that it really pays off to start with the test because you will code faster. So what are the steps of TDD? There are three. The first one is the red, which is making a test that is failing. The next step is to make this test pass. And the final step is to do the refactor. And we will go through each of these steps individually. We also have some rules. And once you write the test, you only are allowed to write production code to make this test pass. You will build a test class and a test scenario and a test method. And after that, the only production code that you are allowed to write is only to make the test go green. Also, please don't write many use cases at the same time. Build one test case at a time, resolve it, and then move to the next one. Why? Because if you create several tests, you won't have a clear input of what is needed to do, what you need to develop. If you are being guided by the test, you won't know what's the next step to make the test go green. Also, whenever you analyze the use case that you need to implement, create a test. And after that, implement the solution. And always the same step. So for that, you will see that your test will be the first-class citizens. They will the interface for your code. They will guide you, and they will also show you some things when you are when you are sympathetic, to know what the test is telling you. Sometimes it's screaming you. You will see that. And also very important is no over-engineering. Try to write the simplest code and make the test pass. And whenever there are more complex scenarios, you can generalize and build more complex stuff. We have questions.
I was just thinking, the developer itself has to generate the test, right? It has to generate a failing test so the program can get better. I don't see how that makes you save time, because if you generate a failing test, that means you found a flaw in your algorithm, and you could have, the thinking process of the flaw in your algorithm, you've already thought about it. I don't see how that basically, when you think of a failing test, you identify a flaw in your existing code. Yes. I don't see how that makes you save time, because when you generate a failing test, you find a flaw in your algorithm. How does that make you save time when you already found a flaw? You can just fix your code.
Okay. So what's the alternative of writing a failing test? It's writing a production code and then manually go through the scenario and then find out that it's failing. There's no way to validate that you have desired behavior unless you test it. And if you test it on the first step, you will be able to see what's failing and what is needed to make the test pass and the behavior to complete.
But maybe I didn't say how are the tests generated?
Huh?
How are the tests generated?
You write the test. You write an automated test and you run it.
Oh, automated test.
Yes.
Oh, okay.
It's an automated test.
Sorry. We look into this because I need to write a test that is very interesting.
I bet you're puzzling.
We get to like how our tests generated. Our talk is just about testing development, which is really interesting.
Yes, I will show you some code as well.
Okay. Thank you.
Okay. Write a test that fails. So the idea is to create an automatic test that will describe the scenario that you need to test, to assert. And the idea is to slow down, try to analyze things first consciously, think about what is expected behavior, and then split this behavior into small testable parts. You create a class, and this class you create a test method which has the required context that you need to test and the expected behavior. The second step, the second cycle is to write the test that is needed to make the test go green. And here is about being lazy. Here you don't need to worry about over-engineering or making complex things. It's about to put the minimal amount of code that you need to make the test pass. You will worry about it on a further scenario where you have the freedom to modify the code to your taste or simplify it as needed. So, are you able to see the screen or not?
No.
Okay. Well, this is a test class in Python that is implemented a library which is called unit test, and it's a unit, it's a test case. And you have a method here that is about generating a list of required number of elements. And you create a class that generates this number and you store it into a variable and do an assertion that the number of elements that the list has is equal to the number of elements that you declare on the top. So we have several ways to resolve this test case. One of them could be creating an array with the number of elements that we expect and return a single number. And another piece of code is using a complex lambda with some transformations within a range using a map and then a list. So from the test perspective, the behavior is the same, but the code here, I think, is more difficult to read, more difficult to maintain, and more difficult to iterate. I will go for the example on the top, because she will let you modify the behavior with further scenarios. Whenever you have more complex scenarios or different use case, you will need to modify the production code. And a better way to modify it is using simple readable code than these single liners that will give you headaches most of the time. So The more specific is the test case. See, here we can have several methods doing some assertions of different numbers. And here we modify the production code and adapt it to be more general to comply with these different use cases. So this is an example of how the test-driven development can guide your code to evolve into something that is more complete. The last step of TDD is the refactor. And as I told you before, when you feel this dopamine injection of having the test screen, it's one of the greatest feeling in the world. The second one, I would say. Here comes the time for refactoring. And what we need to do, what we can do on the refactor, we can see some duplications in the code and remove them. And also we can think about how we can simplify it, how we can make it more readable. Is there a pattern that I could apply, any principle that I could see, some smell that the code has, or is there something that the test is telling me? Most of the TDD adopters say that this is where the magic happens, and they have some concept that is called emergent design. And if you are able to read the code underlines, you can see some things that the test is telling you about the code that you are designing. Some refactoring techniques, I encourage you to dig about them. And this is some common cases of code smells. If you are able to read what the test is telling you, you will find some many common cases. One of them is if you have some difficulty writing the test, this will tell you that you probably have too many dependencies or the code is doing too much, and this is the proper time to refactor it and remove dependencies or decouple or simplify it. Also, if you have too many tests in a single unit, it's probably because you have a class with too much responsibility. Normally we name them the God class because it does everything. You start naming it utility class, and it's an extreme parser, but then you include some authentication method, circuit breaker, resiliency, fault tolerance, and everything is put into that garbage box. So also we encourage to have only one assertion in your methods, to test only one thing per method. If you have too many, it means that your method does many things. So there's not a clear separation of concerns. Your method doesn't have a single responsibility, and it's a perfect time to extract this functionality to another method that you can test separately. Also, if you are testing too much a component, it's also an architecture smell that you are building a monolithic application. It's also a good opportunity to decouple into some modular applications that can run separately. And also when you have to modify your production code and you see that then there are some unrelated tests that are failing, it tells about the cohesion and the coupling of your code as well. There's another example. I hope you can see this better. No? Okay, this is some code. This is some code in Java, and it's a car class. Okay. Now.
Yes.
Okay, so this is a car class that has an engine collaborator, and has a method that is called start the car, and uses another method which is put on the neutral gear, apply some brakes, and make the engine start. And it looks okay, it looks pretty fine, it looks like it can work, but then when you have to test it, you cannot do any assertion of it because the methods are private, they don't return anything, and the engine is coupled to the car, so it's very difficult to test. So, but if you, instead of starting with the production code, create a test that says the car should start the car engine when I start the car, you have the assertion telling that the engine will be on whenever I start the car. And here also I can do some decoupling using a fake engine. And I could use any other type of engine. I could use diesel engine, an electric engine, or a jet engine to test this class, and then the production code will look much better. This is more testable. This is something that you can decouple, and this is something that you can test it. We are almost finishing. This is more like a controversial statement. TDD has nothing to do with testing. It's more about a development strategy where you have some specifications that can be automated and you use them to test your code. It also has been said that TDD slows down your velocity because you have to write the double amount of code, because additionally to write production code, you need to write the test and you need to invest some time in writing both of them. But at the end, this is the idea. You slow down, you think consciously about the use case, what's the requirement, what's the expected behavior, and you solve the problem instead of hacking it like a monkey, you know. When you write your production code and then you write the test, what you are doing is validating your implementation of the code. And if you change your implementation, you will need to change the test. But if you write the test first with the expected outcome of what you're building, you can change the implementation, and if the behavior is the same, you are not breaking your production code. So this is a way to go slow, to go faster at the end. Some resources, well, there are plenty of literature, but I can recommend Test-Driven Developer by the creator, which is Ken Beck. Also, there are some refactoring techniques by Martin Fowler. It explains what are the most common code smells and how to resolve them. There are also design patterns which let you will help you to simplify your code, applying some general examples for common use cases, and also drawing object-oriented software, which is guided by tests. And there are other ways to learn about TDD. What I recommend the most is to do pair programming. Look for someone who is familiarized with this technique and book for a time slot and sit down and do the testing. Two people, one single computer, write the test, write the code, switch the roles, and do it again. This is a discipline that is learning by doing. You will not master it tomorrow or even the next week. It's something that you will need to invest some time. But it's for sure very useful in your developer toolkit. There are also something that is called coding dojos or coding katas, which are code examples that will force you to take some decisions based on the test that you are writing. And there are also some constraints that will help you in master some techniques about coding. And it's an open space where you can go and practice them without being worried about the result. In a coding dojo, you are not required to finish the solution, but to learn something and to interact with your co-worker and share your learning and learn from someone else's experience. And if you don't have time to do super programming or coding dojos, you will always have YouTube. There are plenty of videos or screencasts demonstrating examples with your favorite programming language. There are also platform and courses and training about TDD that you can follow. And what else? Well, this is it. Do you have any questions? Or the audience online? I don't. No? Nothing?
This concept for tests, you should, when implementing a new class, for instance, you sketch out all the functions, all the methods you should use, and you start by imagining first the tests and then trying to implement the functions. And if your function requires to implement more functions, but these functions come from this original function that, for instance, if you have, I imagine, like an instrument where you need to control, the players that are there. Like you will start writing the test and then trying to implement it. And if it requires implementing more methods, you should try to write tests for those methods as well.
Yes, but this is a sign that you are not testing the smaller part, and then you should go to the other method and start writing some tests for this piece of software.
I should start by the smaller part.
Yes. There are some other tools like outside TDD, which instead of starting from a minimal part,